Hello everyone, hope you are doing well. So, in this lecture, we are going to discuss about some of the few questions because there's no point doing all that stuff if we are not able to apply whatever concepts we have discussed into practice, into questions. So, we are going to discuss a few questions based on all the content which I have discussed, whether it's atomic number, whether it's mass number, electronic configuration, ions, everything. So, the very first question that I'm going to write over here. So, the number of electrons in the valence shell of chlorine atom and lithium atom. So, number of electrons, so we can add one more point over here, the total number of electrons in the valence shell of chlorine atom and lithium atom. So in order to answer this, now just remember one thing, what we are discussing over here is either very concept based, objective type of questions. Multiple choice questions can also be made out of these questions. So either it's a subjective question or it's an objective MCQ. It doesn't matter if your concept is clear. So main over here in these practice question is to get an idea what kind of questions they can ask, to get an idea about the concept, where do you stand in terms of conceptual understanding and knowledge. That matters most compared to the MCQs, or you can say multiple choice questions. So even if you don't have four options, so basically there's always not always, there are some exams where multiple answer type questions are also there. So main thing is that we need to find the correct answers, either it's single answer or multiple answer. So if we read the question and it clicks to our mind that this is the correct answer out of all these four, and we are 100% sure, that means our conceptual understanding is quite well. So the other options given in the multiple choice questions are only to confuse you. So, what do? We read the question, then we jump to the MCQs options over there, and we start figuring out ourselves or trying to confuse ourselves in the brain, when we can just focus on the question and just try to get one single answer out of it. And if it is matching with our options, then for sure, like, it's correct. So main thing is about conceptual knowledge and understanding. So total number of electrons in the valence shell of chlorine atom and lithium atom. So before answering this, what we need to remember is chlorine atomic number is 17, lithium atomic number is 3. So we know its electronic configuration will be 287 and lithium will be 2 and 1. Now, total number of electrons in the valence shell of chlorine atom and lithium atom. So, if you sum it up, 7 plus 1 is going to be, valence shell is this. So, 7 plus 1, that is 8 electrons. So, this is our answer. Total number of electrons in the valence shell of chlorine atom and lithium atom. Now, if I twist this question, like slightly, the total number of electrons in the L shell of nitrogen and potassium. So, what is going to be that answer? So, we know nitrogen, atomic number is 7, so 2 and 5 configuration. Potassium is atomic number 19, 2881 configuration. So, L shell is going to be this is K, this is L here. So, they are specifically L shell. So, we have 5 electrons from nitrogen and we have 8 electrons from potassium, so this will be 13. So 13 electrons sum is your answer. Then if we go to another question, this is going to be a little direct. Write the formula of given radicals along with their charge or collective charge. So first acetate, dichromate, ammonium, sulfate. Now in these questions, what you can do is you can pause the video and you can answer. Obviously that honesty is required from your side not from my side, so you can pause it and you can think over it, and if my answer your answer matches, then bravo, you have done a good job. So now this question is very direct. I'll definitely twist it a little bit in the next question, so we'll write the answers now. Formula of given radicals along with the charge. Acetate is CH3COO minus. You can remember it from acetic acid. That is, it's the IUPAC name of acetic acid is ethanoic acid. We write like CH3COH. So it's our acetate radical. Then dichromate, chromium is there. Di stand for two chromium atoms. So it's an ATE suffix, definitely oxygen is there. How many? You have to remember it. Cr2O7, 2 minus. Then C, ammonium, that's the only cation radical which I discussed in these lectures, that is NH4 plus. Then D, sulfate, SO4, 2 minus. If you remember, sulfate having more number of oxygen atom, SO4 2 minus, SO3 2 minus is sulfite, no oxygen atom, S with a minus 2 charge, sulfite. Now the fourth question. Write the formula and atomicity of the following ions, or you can say radicals. So the very first option we are going to write is zincate. I'll explain what atomicity is. So I could have introduced atomicity before also, but I'm introducing a concept along with the question. Zincate, then we can write nitrate, and we can write phosphite. So now, in order to understand this question, we need to address what atomicity is at the first place. So I'll explain this part. So atomicity is the total number of atoms in an ion, molecule, compound, anything. It's a total number. So based on atomicity, based on this definition, so atomicity can be monoatomic, so it can be diatomic, or it can be polyatomic. So polyatomic means many. Mono means atomicity is just one. So we can write examples as metals, it can be noble gases. Noble gases are very much monoatomic. So if I'm writing noble gas neon, we are going to call it as just one molecule. Then diatomic over here is going to be your atomicity from the term di, it is 2. So it's going to be oxygen gas O2. So this subscript, can you see, this indicates two atoms of oxygen chemically bonded to form one molecule of oxygen gas, the same oxygen that we breathe. Then if we can write hydrogen gas is also diatomic. Chlorine is diatomic. If you remember that fluorine, chlorine, bromine, iodine in the previous lectures, they are halogens, they are all diatomic. You can write all over here. So, like, etc. Then we go to polyatomic. So, polyatomic, that means it can be many. So, anything beyond 2, it can be triatomic, it can be tetraatomic, it can be pentaatomic, anything. So, we will write under this as example O3, which is our ozone. This is triatomic, so that means its atomicity is 3. We can write P4, this is phosphorus molecule. This is tetraatomic. Then we can write S8, this is sulfur molecule. Sulfur, 8 sulfur atoms will be chemically bonded to form one molecule. This is octatomic. So these are multiple examples. Now if we have understood this atomicity pretty well, we can go to this question. Now I'll be taking the first A part, zincate. So zincate, if you can see the previous charts which I have given, that is ZnO2 with the 2 minus charge. Now the atomicity of zincate is going to be what? We can see from the formula there is one zinc atom over here. Oxygen, 2 atoms are there. So if you add it up, this will give you atomicity 3. Then we go to the second option, nitrate. So nitrate is NO3 minus. Now irrespective of the charge, so how many atoms do we have? Nitrogen is 1 atom. Oxygen, how many atoms? 3. So total will be 4. So this is tetraatomic. Now, it can be a molecule, it can be a compound. You can apply this concept throughout chemistry, anywhere, in the ion part, in the molecular part. So I'm basically adding in the this is what I have written, monatomic, polyatomic. This is for molecular part. So atomicity is on a standard rule, it is always calculated for the molecules. But if somebody is asking in the question on a theoretical ground how many atoms are there, total atoms in the radicals or ions, then why not? We can answer. So it's a very generic term. Then the third one is phosphite. PO3, 3 minus. So 1 phosphorus atom, 3 oxygen, total is 4. So we have nitrate, phosphite, tetraatomic, triatomic, that is zincate. So you should be very much equipped to learn all these kind of questions. So we'll go to the next one. What are the valencies of the following atoms or elements? So first one, we will take oxygen, sulfur, carbon. So oxygen is atomic number 8. So 2 and 6 configuration. From here we can govern that it requires 2 electrons to share or gain in order to complete its octet and have 2-8 configuration, that is neon configuration. So its valency is going to be 2. Or you can remember it from this, if you have memorized O2 minus, this ion, this number basically indicates the valency of oxygen, so the oxide part. So this is A part, B is sulfur. Sulfur atomic number is 16. So this is 286, 6 valence electron. Again, how many electrons it require to share, to have octet? So it's 2. 8 minus 6 is 2. So, or you can remember like this, there's the same number. Then we have the third one, which is carbon, atomic number 6, 2 and 4. So 8 minus 4 will give you valency 4. Now, we do have this ion C4 minus. This is called as carbide. We do have a lot of metal carbides, but do remember we write 4 minus on a theoretical ground, but it's not going to accept 4 electrons. That part about carbon we can study in the organic chemistry lectures in the future. So we can write C4 minus, it's carbide for sure, but it's very difficult for carbon to to accept 4 electrons due to so many reasons. So that we'll cover it somewhere in organic chemistry. So I hope you understood all these questions, and I hope you have already started memorizing all these basic concepts for understanding future lectures. So thank you for learning along with me.